Okay, back. Woo! Got me some water. Used little boy's room. Feeling good. All right, now that was probably TMI. You probably didn't need to know that, but anyways. Oh, so what happens? So I gave you a bunch of drawings here, and of course, over the last time we've actually met in Zoom, I went through 3 different types of basic problems. And most drawings are like those. So, you want to use those as a guide. And of course, I gave you one of those 3 basic problems in the mirror thing. And I did another one on the board behind me. It wasn't quite the same as those 3, a little different. But we went through it and we used the same 3 lines. We always do that. But what if we have a weird kind of a case where, it's like one of the lines that we draw in one of the problems ends up being parallel with another line. What if those 2 lines end up being parallel to each other? Okay, if that happens, if you end up getting 2 parallel lines after they bounce off the mirror and they're parallel, it'll never intersect. That's a case where you would have no image. It would be no image. Do you remember the funkiness? I was trying to show it to you at home. People here that were here could see it easier with the BFM. There's a hang on, okay. Yeah, you can see the classroom. Okay, it's Wednesday, Veterans Day, and I'm in here dedicated to my students. You're my favorite group of students that I have this year, so I'm here for you. Yes, I am. And so you can see everything's upside down in the back of the room. Now, if I get close, okay, it flips upside, if it's right side up, and things look big. Look how big those flags are in the back of the room now, compared to what they are back here. Okay, they're smaller. Okay, but then also, there's a weird point. There's a weird point, like right here. Whoa, dude. Oh, what's going on? Oh, wait a minute. Actually, that wasn't it. Oh, yeah, no, it was. This is so confusing. I'm watching this and I'm watching that, and I'm like, oh my God, my brain is going nuts here. Okay, so right side up. Everything's right side up. Pull you back. And then upside down. So right side up, upside down. Now there's a point right about here, right there, where everything goes away. Everything's gone. Upside down. Upside down. I'll move that up a little bit. And then weirdness. My brain, I can't take it. What's going on? Drugs. Oh, this must have been like it was like in the 60s. Yeah, okay. I don't know. Personally, I don't know, okay? All right. Now this, all of a sudden, is right side up. So we have this funkiness in here, right in here. I'm moving this back and forth with about 1 centimeter, and there's no image being formed. When I move him back to that point, we get an image. It's inverted. When I move in front of the point, we get an image. It's upright and enlarged. That is the point of funkiness. That's not actually a technical term. I made it up. Hang on, putting this back. So what's going on there? Well, I actually have given you a drawing like that to see why you get funkiness. And the drawing hopefully will help you see that. I'll give you a hint. You should have parallel lines in that drawing. I'm not going to tell you which one it is. You kids figure it out. You want me to do everything for you? You want me to draw these for you? Okay, I'll draw them out, and then I'll go to Dunkin' Donuts and get you some coffee and donuts and a warm blanket. All right, you figure it out. You'll get there. When you find out which one it is, you'll know. It's like love. It's just like love. You'll know. Okay? So you'll know which one I'm talking about. And in that case, you'll have parallel lines and you're not going to get an image. So what do I say? What's my descriptor words? If you don't have an image, you can't describe the image. So you say, no image. And then you do the math on that, and it's cool. You find out what happens when the math on that. You go ahead, put the numbers in, and see what happens, and you'll get like, whoa! You'll get undefined. Undefined means you get no image. Okay, there's my hint. You got one like that, okay? Let's see. There's another one where I have the object at the center of curvature. I do. I put it right in the center of curvature. And in that case, you're just going to use 2 lines out of the 3 to get the image. Because if you're at the center of curvature, you can't really go through the center of curvature now, can you? Okay? You can't. Like, so for example, you're like this, you're like this, you're like this, you're like this, you're here, you do this, you do that, and then you do this. You go, I go straight through, I gotta go down through the center of curvature. You don't have to do that. You actually only need to have 2 lines to see where an image will be. The third one is just a check, it converts it. The third one's an Eastern European, okay? It's an Eastern European. It's a check. Check. Hey. Yeah, so you don't need to have that third line in this case. So when the object is at the center of curvature, just use your two lines here. And if you've done it right, I did this, of course, really quick freehand. These are going to end up right below here anyways, a little bit off, but then again, it's moving fast. So you do it accurately, and hopefully you'll come out with a nice connection right around that bottom, that center of curvature, and don't worry about that third line. You're good with the two. Okay, all right. Okay, I think those are like the special cases for the mirror drawings. Okay, I think. Oh. Let's try that again. Follow through. Woo. Yeah. Tiger Woods. Where was I? I don't remember. Oh, the special cases. Oh, yeah, so I think that'll take care of them. Oh, wait, one more. I thought you were going to get away with it, too. I would have if it wasn't for you meddling kids. Okay, you have one where I'm going to ask you to draw using a convex mirror. Don't do anything different. Well, of course, I drew this. You're not going to do that until you get your center of curvature. Let me do it how you would do this. You would... Okay, there's my mirror, there's my focal point, there's my center of curvature, and you go ahead and you set it up the same way. Then use your protractor, what do you call that thing? That's a compass. Compass! Use your compass, or use your dots, and draw that in. You're good. But this time it's concave. What do I do now? Put the object on the other side. Put it over here. Set it up the same. Be consistent. Okay? Less chance of error if you're consistent. Put your arrow over here. Measure from this point. Arrow over here. Then you'll go ahead and draw those lines and look at the example that I gave you in class. If you didn't copy it down, too bad for you. And if you don't have it and you need it, go ask somebody, because somebody in your class was smart enough to take that down. All right? And then it'll be like the example in class, the third example I did in class for you this week. Okay, yeah, that should do it. That should, oh, no, it won't. I got one more thing. That's why they paid me $1.4 million, because I think of this stuff. When you go ahead and do a math calculation with the convex mirror, something muy importante grande you need to know. You do the math, all right? So here we go. 1 over di equals 1 over f minus 1 over dl. Right? Okay, good. Yeah, we've done that. Okay, good. This focal point is in the mirror. On the side where the object is the real side. This is the virtual side. Anything virtual is a negative. So you can get negative numbers, and there is one. Well, we have a concave mirror, and we put the object very close to it, and we got a magnification of an object in back. You do the math on that, you will get a negative. You haven't done anything wrong, you'll get a negative. Why? Because it's in the mirror. In the mirror is virtual. Virtual is designated by a negative. Negative is in the mirror. So when you do the math on this one, and some of you will forget this, and when I ask on the academic adventure that's coming up after Thanksgiving break here, you will forget that this is a negative focal point, and I have to put a negative here. Why? Because the focal length is in the mirror. It's in the virtual realm, so you've got to put a negative there. That changes all the math. So you have to remember that when doing the math. So if you do this out and you get an image, probably somewhere in here, and it doesn't match up with this, the math that you did is because you forgot with the negative here. And when you get the distance of that image, it will be a negative number. You haven't done anything wrong, it just means it's virtual. Okay, I think those are all the good reminders. So I think you kids are going to be able to go off and run it. I'm exhausted. You see how far I ran? Want to see me run to that mountain and back? Want to see me do it again? Oh, wait. Woo! Okay, kids, I think that will wrap that up. I'll load these up, and then you can go ahead and look these through, work on these mirror drawings. If you have any questions at this point, then you can ask me individually. Okay, adios, muchachos grande.